Welcome back to another rendition of Math is Easy Step by Step. So here's a quick review again, a visual representation of what are fractions. So when you have a whole, it's not broken up into any parts, it's one whole. And then if you took that whole and you separate it into two pieces, that represents your denominator, two parts. And only one of those two parts is colored in blue. So half of this square is colored in blue. Take a look at here at this next square. We have it, or rectangle, broken up into three different parts. That represents your denominator. And only one of those three parts, 1 out of 3, or 1/3, is colored in purple. And finally, a quick visual look here. We have this rectangle broken up into 4 parts, which represents the denominator, 4 pieces, and 3 out of 4, so 3 out of 4 are colored in green. So, as mentioned before, I sure like to go over some examples of adding fractions, and then, of course, one more example of subtracting fractions. So here, in this original problem, I have 1/2 plus 1/7. And I don't know what two numbers 2 and 7 share. So I'm going to set up a t-chart with both of the denominators in the top. I'm going to multiply each of them times 1, times 2, times 3, times 5, times all the way down to times 10. And I'm going to look to see which number that they both share. Well, 2 times 7 gives me 14, and 7 times 2 also gives me 14. So in order to manipulate and create a common denominator of 14, I'm going to multiply 7 times 2. What I do to the bottom, I have to do to the top. And then to create a common denominator, 2 times 7 is 14. What I do to the bottom, I have to do to the top. So 1 times 7 is 7 over 7 times 2 is 14. Plus, we have 1 times 2 is 2. 7 times 2 is 14. We have that common denominator. And if I am going a little too fast, please rewind. You can watch this as many times as you like. So the bottom number is the same. The denominator is the same. Then we can add or subtract the top. 7 plus 2 is 9. And that denominator stays the same. Now, you have to ask yourself this question. This is part of the final solution or answer that you have. Is there a number I can divide evenly into both top and bottom without a remainder other than 1? I know 3 will go into 9, but 3 will not divide evenly into 4. I know 2 can divide into 14, but 2 cannot divide evenly into 9. So what are we looking at here? Since there's not a number that can be reduced into 9/14 evenly, top and bottom, we're looking at our final answer of 9/14. Now, I said I'd also do another problem of subtracting. So here we go. Here is 1/12 minus 1/16. So again, I'm going to sit here and go, these numbers in the denominator or the bottom are not the same. I have to manipulate these fractions so these bottom numbers would be the same. So I set up my t-chart with both of the fractions at the top of the chart. I'm going to multiply each of those numbers starting with 1, then 2, 3, 4, all the way down until I find a number that they both share. Well, here you can see 12 times 4 is 48. And you can see 16 times 3 is 48. This is the smallest number they both would share. So I'm going to multiply top and bottom. I'm going to multiply 16 times 3, top and bottom. I'm going to multiply 12 times 4, What I do to the bottom, I have to do to the top. So here you can see, again, I'm multiplying 4 times 12. 4 times 12 is 48. What I do to the bottom, I have to do to the top. 4 times 1 is 4. Minus, again, 16 times 3 is 48. So I do to the bottom, I have to do to the top. That's 48. And 3 times 1 is 3. Now we have the same common denominator. We can now subtract the values on top. 4 minus 3 equals 1. 48, 48. The denominator stays 48. Is there a number I can divide in the top and bottom evenly without a remainder? Other than 1? No, there is not. So this is my final answer. 1/48 is the answer to this particular problem. Hey, I hope you found this helpful. Math is easy, step by step.